Let's take question number 54. Simple one. This says a function is there given by x cube plus x plus 2. Then the function is 1 1 on 2 into many 1. The four combinations we have to judge with. Let's begin with this question. When you differentiate this function, it is going to give 3x square plus 1, which is clearly greater than 0. What does it mean? Function is a strictly increasing function. It's going to increase with every increasing x. What's the resultant? When you say function is a strictly increasing, yes, this function is 1 1. When the function is 1 1, it is increasing. Its minimum value will be obtained at the first point and the maximum will be obtained at the last possible point or the last approaching point. Here the domain is real numbers, so the minimum value will also be approaching to minus infinity when x is approaching to minus infinity, and maximum would be approaching to plus infinity when x is approaching to infinity, meaning the function is onto as well. So yes, it is 1 1 onto function. So I'm sure this question is clear and its answer is option number 4. Let's consider the next one, that is question number 55. Consider the function given by this complex situation, which includes inverse as well as some lengthy term. Then the equation fx equals 0 has no real solution, has infinitely many solutions, etc. So let's understand basically what the question is saying. When you closely observe the function 9 sine inverse root x, 6 pi cos inverse root x, you can change it to sine inverse root x. Yes. Root x by 3, 1 by 4 root x, 1 by root 3. So some relationship is there amongst all the terms. What kind of relationship? Let's understand. So let's understand how we can solve this simple question. So here when you rewrite this thing, the equation changes to 3 sine inverse root x whole square minus 6 pi sine inverse root x. What I have done, I have rewritten cos inverse root x as pi by 2 minus sine inverse root x so that I can convert into a perfect square. Now, in order to make it a perfect square, what else is required? Pi square term. So this is simply a perfect square. Now let's see what we are left with. Checking again the equation, root x by 3 minus 2 pi square plus 1 by 4 root x minus 1 by root 3. Forget about minus 2 pi square for the time being and consider these three terms. Root x by 3, I can write x to the power 1 by 4 by root 3 whole square. I am again making it a perfect square. Minus, next term here you have 1 by root 3, correct? Plus you have 1 by 4 root x. This 1 by 4 root x can be written as plus 1 by 2x to the power 1 by 4 whole square minus 1 by root 3. Now just consider, when you consider a square plus b square, so what is 2ab there? 2 into this term, right? 2 will be cancelled, x to the power 1 by 4 will be cancelled, 1 by root 3 is a remaining term, meaning this is exhausted. Now, when you have changed to sine inverse root x from cos inverse root x, what was there actually? 6 pi multiplied with cos inverse root x. So this became pi by 2 minus sine inverse root x multiplied with 6 pi. So this 6 pi is multiplied to pi by 2, making it 3 pi square minus 2 pi square, that is simply pi square. So every term is exhausted now. So let's write down, this is your fx. This is equal to fx. Therefore, fx is equal to 3 sine inverse root x minus pi whole square plus x to the power 1 by 4 upon root 3 minus 1 upon 2x to the power 1 by 4 whole square. Now I am looking for the solutions. Fx is equal to 0. This means you have sine inverse root x is equal to pi by 3 or root x is equal to root 3 by 2. Now the second one is giving me x to the power 1 by 4 upon root 3 is equal to 1 upon 2x to the power 1 by 4, or root x is equal to root 3 by 2. So clearly, how many solutions we are obtaining? Yes, just one solution is being obtained for the required equation. Let's check from the given options. When you see the first one, no real solution, no, it is not correct. Infinitely many, not correct. Unique solution in the interval 0 to half, unique solution in the interval half to 1. My answer is from these two, x is equal to 3 by 4. So x is equal to 3 by 4, meaning lying in the interval half to 1. So which one is the correct answer? Yes, option number 4 is the correct answer for this question. So let's mark it. I'm sure this is clear. Let's move on to the next one. So let's consider question number 56. If alpha is a real solution of this given equation, then alpha lies in the interval which of the following one? The 4 from. Now, considering this question, I can rewrite it as pi by 2 minus cos inverse x is equal to tan inverse x plus cos inverse x. Now, I can consider this one as pi by 2 minus tan inverse x, that is cot inverse x, is equal to 2 cos inverse x. I'm sure this is clear. Now let's draw the graph for the two terms. One cot inverse x, another one 2 cos inverse x, right? So when you draw the graph for the two, you can see graph for cot inverse x will be like this. Graph for cos inverse x goes in this fashion, but 2 is multiplied, so range is doubled, so it goes in this fashion. How many points of intersections you observe over here? Just one. So what is the correct answer for this question? Just one. Now let's check out from the given option. Alpha is a real value, then alpha lies in which of the following intervals? Now interval is being asked, so you can see here this is the value 1. So clearly this value is lying in the interval 1 by root 2 to 1. So the correct answer is option number 4. I'm sure this part is clear how we are getting this 1 by root 2 to 1. Let's move on to the next one, that is question number 57.